Once you got the idea, how do you actually start designing a product? I know it's very tempting to jump straight into the design phase, but if you skip step 1, which is defining the requirements, your project will most likely fail. So we need to get back to what people, your potential customers, actually want. Once we have the list of requirements, we can break them down and we will get the technical details that we need for the implementation. If you want to see a sneak peek of the circuit board design, stay until the end. If you haven't seen my previous video, my name is Sarah. I'm a solo engineer and I'm building a commercial product from scratch, while also showing the journey on this YouTube channel. So I'm gonna be sharing everything, including the parts that don't work. So back to our requirements. The person who I'm building this for is someone who is interested in knowing if the air inside their home or office is stale or fresh, and is interested in tracking their exposure to pollution while they're commuting or going out or traveling or whatever. A good way to check if there is demand for something is to do what is called a keyword search and look at what people search on Google. In this case, I checked the keywords air quality monitor, and here you can see that it has a global volume, which means how many people search this every month, of 47.8 thousand. And I know, of course, this doesn't mean that all those 47,000 people are gonna be landing on my product's website, but that's gonna be my marketing challenge. For my product, I have listed 4 high-level requirements. The first one, as I already mentioned, is it needs to measure CO2 and particulate matter. The second one, it needs a way to show this data that is gathered from the sensors. The third one is about portability. I want this device to work both indoors and outdoors and be easy to carry. Which brings us to the 4th requirement, which is it needs to be compact and low cost. Looks easy and simple, right? But let's break them down one by one. Number 1, the sensors. These sensors basically define the whole product, and they're the ones that provide the data for the most important customer-facing feature. So for CO2, I'm using the Sensirion SCD43, which is this little cube here. I'm not a sensor expert, but this sensor is very accurate and it's relatively small, so it fits my purpose well enough, and also has integrated into it humidity and temperature. Plus, Sensirion is trusted in this industry. The only thing that I was wondering was if I should use the predecessor SCD41, but since they have the same form factor and this one is more accurate and only, I think, a couple dollars more expensive, I decided to go with the last one. The particulate matter sensor is quite interesting. Most of the PM sensors on the market have a fan because they need to redirect the airflow to the specific sensing area. And then there are lasers pointed to the air. How much these lasers get scattered gives us an indication of the PM in the air, the particles in the air. And then there are algorithms to convert that into PM1, 2.5 and 10, which are different particle sizes. So you can imagine that having a fan in a portable device is not great. It's gonna consume more power, it's gonna require more space, and it's also one more thing that can break. So this sensor, which is the Bosch BMV080, is very special because it doesn't have a fan and is 400 times smaller than other traditional particulate matter sensors. But it also comes in a weird form factor. The sensor sits on a flexible PCB and you need a special connector to go with it, this one here, and then it needs a quite large heatsink. Here you can see a PCB heatsink, and it needs a lens to see the world through. So I obviously chose this sensor because it's really small and compact, but since it's quite new, I think it was released in 2023, it's very expensive. Like one of these sensors costs like about $32. So yeah, these 2 sensors alone are gonna cost me like $50 per unit. The sensors alone won't do anything. They need something that can read the data from them, convert the data to a human readable format, and send the data out. That something is a microcontroller, which is what you call this tiny computer that is used in embedded devices. There are a lot of microcontrollers on the market. You might have heard of ESP32, Arduino. I've worked with Nordic semiconductor microcontrollers before, and I really like them because they're low power and they have great customer support. But it also comes down to personal preference. Someone else maybe is more familiar with another brand of microcontrollers. The specific microcontroller that I chose is an NRF54, which is the successor of the NRF BMV080 has more memory and it has like half of the power consumption, so it's just a no-brainer. Let's pause for a second. If you make a design using the raw chip, then you're gonna have to design a Bluetooth antenna. And since we're using Bluetooth, the EU has the Radio Equipment Directive, and you need to be compliant with this directive if you want to sell your product in the EU, which of course I want to. So here, instead of doing my own design, which I by the way did before, this here is the first PCB that I designed. And if you see here in the top right here, it has a PCB antenna. And it works. I could connect this to my phone via Bluetooth, but my design is suboptimal. So for the sake of making my life easier, making the certification easier, I'm gonna buy a module. And I've selected a module from this company called Raytac. So basically what they do is they take the nRF54 and they wrap it into a module. They design the PCB antenna into this module and they pre-certify it. In case you didn't know, certification is expensive. Choosing components is not a linear process. Sometimes you choose a component and then you find out that it doesn't fit a later requirement. So for example, it could be that it has a very specific temperature range. It doesn't work if the temperature is about 25. And then you know, okay, I cannot use this component. Another thing that you need to check before locking in a component is how hard is it to source it? So where can you find it and buy it? And this is a bit tricky because, as I mentioned, these parts that I've selected, they're quite new in hardware terms. They've been released in the last 2 years, so they're not easily available. If you want to quickly check if a part is easy to find, you can go on this website, Octopart, and paste the part number. And this will tell you which distributors have it and how many units they carry and how much they cost. So yeah, it's a lot of things to think about when choosing the components. And if you rush this phase, you can make mistakes that make your life harder later on when you maybe have designed a product and are already selling it, but then suddenly you have to remake it. That brings us to requirement number 2, which is we have these sensors that gather data about the environment. We have a microcontroller that reads these sensors, but we need to display somehow this data to the user. And how I decided to do this includes also how I decided not to do this. A display could be nice, and that is true. I also thought about putting on a display. I decided against it. It will draw more power and it will take more space. So it would make the device thicker and more expensive. It means adding a step during manufacturing. So it's an additional component that needs to be picked, put in place, and it will have a connector that will go into the PCB. And every step in the manufacturing process will add cost and complexity and things that could break or go wrong. The device will have an LED, like a multicolor LED, that can show at a glance the current air quality. And then, since we have Bluetooth, the device will be publishing the detailed sensor information to a mobile app on your phone. Wi-Fi is not suitable for this project, as you might have already guessed, because the sensor is portable, so it's not gonna just be sitting home where you can connect it to your Wi-Fi. That brings us to requirement number 3. Portable sounds easy, but when you look at it, it means that you need somehow to power your device, and that is done using batteries. But batteries come in all forms and shapes, so the first question is, what kind of battery should I use? And you also want a battery that is rechargeable. It needs to be compact because you need to put it into this device. And ideally it should also be like a common battery that you can find and source easily. And that sort of narrows it down to lithium polymer batteries. It's the same battery chemistry that is used in smartphones. Here is a battery that I had from a previous project. These 2 batteries, which are in a pouch shape, and I think the battery that I will go with is gonna be slightly bigger, but not super much. Another interesting aspect is, if you look at this battery, this part at the top, so this is a protection circuit for the battery to protect it against overvoltage, overcurrent and short circuits. And the fact that the battery has it already here means that I will have less parts on my circuit board, which is nice. So to decide which battery to pick, an important thing is the capacity, which means basically how long will this battery last. To calculate that, you need to know how many days you want your battery to last, and then you need to know how much power each component on the circuit board will need. Here I've used my helpful assistant to do a rough calculation, and that came back to, if I want 5+ days of usage before needing charging, then I need around 550 milliamps hour. Now I have a battery specification. I still haven't found the right battery yet, but I have a battery in mind, but I just need to make sure that it's possible to actually buy it. So I've sent an email to the supplier to ask them if it's available and how much does it cost and what is the minimum order quantity, which is another thing that you need to think about when you're choosing components, because manufacturers want to sell you as many parts as possible in one go. When you make a product that has a battery, there is a boring but important thing that you need to consider, which is again regulation. So if you want to sell a product that has a lithium battery in Europe, you need some paperwork, of course. The good thing is that the cell manufacturer, the battery cell manufacturer, will do most of this paperwork for you, but this also means that you need to buy from a reputable supplier. Like, you cannot buy a cheap battery from, for example, AliExpress. And we're not done with the battery, because the battery also needs charging. So for charging, you will probably need PMIC, which stands for Power Management Integrated Circuit. And while doing research, I discovered this cool chip from Nordic Semiconductor, which is the same manufacturer of the microcontroller. So this chip, which is called MPM080, will have many functionalities. It's the charger, and it's also gonna track the state of charge of the battery, and it's also gonna act as a safety. It's gonna be connected to the on and off button. So instead of having a switch to disconnect the battery, I can use this chip. And it's also gonna fulfill the functionality of a watchdog, which is basically a mechanism that you want to prevent your device from breaking. You can break a device, for example, with a bad software update. The only way to come out of this situation is a hardware watchdog, which basically means there is a signal going from your microcontroller to the watchdog, and if this signal doesn't come in a certain amount of time, the watchdog will power cycle your microcontroller, making it restart. So without this chip, I would need 5 separate parts. Okay, so now we come to the fourth and last requirement. And the biggest piece in this device is gonna be the circuit board. So how do you actually make a cheap circuit board, or PCB? I have 4 tips for that. The first thing that you should consider is how these PCBs are manufactured. For example, you can see this PCB has 2 layers and it has components on 2 layers. If it has components on 2 layers, they will have to assemble the first side, and then they will have to flip the board on the other side to assemble the other component. So if possible, like if you have enough space, you should keep the components all on the same side of the PCB. The second thing that you should consider is use standard components. This basically comes to what the manufacturers usually have in stock and what the manufacturers have already pre-mounted into their assembly lines. So if you use a component that is very widely available and it's standard, then you're gonna save money. Another thing that drives the cost of the circuit board is the size. If your PCB is very big, it's gonna be more expensive. And lastly, a thing to think about is the type of component. So there are 2 types: surface mount components or through-hole components. These 2 types of components need 2 different machines to be assembled. So if you choose only one type, then you're gonna save an assembly step, and that's gonna make your design cheaper to manufacture. Alright, so now to recap, we have this architecture that you can see here. We have USB-C to charge the device. So this power management circuit is gonna be interfacing between USB-C and the battery, and it's gonna be converting these inputs to the power needed by the microcontroller module and the sensors. The SCD43 has special power requirements. It requires its own low noise 3.3 volt power line. So now to the fun part. Last week I spent time doing the schematic for the circuit board, but I'm not ready to order the prototypes yet. There are still a few unknowns to be sorted and I have to finalize the layout. If you reach this point, I have a little game for you. Comment down below how much you think the circuit board will cost. Assume that I'm gonna be ordering 5 units. But honestly, the schematic is not the hardest part. The hard part is what comes next, and it's called Design for Manufacturing, or also DFM, which basically means making sure that all the parts can fit together and this final product can be manufactured and assembled. Before I wrap up, I just wanted to say thank you to all of you watching. Honestly, I did not expect my first video to get the response it did. This is filmed week by week, so what you're seeing is basically real time what I've been doing. And I don't know what's gonna work and what's gonna break, but there is only one way to find out. I'm Sarah, this is Busy Wait. See you in the next loop.